Okay, my presentation topic is vertical distribution and the migration patterns of Nautilus pompilius. And let's give a short introduction of Nautilus. They call it fossil because they look very similar compared with their fossil ancestor from millions ago. And many people want to they are sure for collection purpose. So now they are under the strong survival stress. And this creature living at a water depth of 50 to 300 meters, and they prefer to stay in the cool water between 15 to 18 degrees Celsius. And the temperature cannot exceed in 25 degrees Celsius, and if the temperature is over, they will soon die. And they have the longest lifespan around the cephalopods. The common cephalopod like octopus or squid only have 1 or 2 years, but they have almost 20 years. The largest species can almost about 50 years. And they are capable of metabolic suppression in an axial and low temperature like in the deep sea. Also, the research contribute the depth record of Nautilus is located in 703 meters, and they are opportunistic feeders, and it means it can scavenge their body like this, like dead fish, descending from the surface, or they can choose to prey on crustaceans like shrimp or crab. And next is introduce about the vertical migration. Vertical migration means the creature will migrate into a sunlight area about 200 meters to feed under the cover of the dark. And when it's daytime, they will return to the deeper depths to avoid the visual predator like seabird, shark, or tuna, the large fish. And this movement pattern has been documented around these three primary populations in Palau, Manus Island, and Port Moresby. And just we mentioned before, in the night they will migration into a 100 to 200 meters for feeding, and when it's daytime they will go down to 250 meters to 300 meters and for resting. And we've discovered this movement pattern in these three primary locations. So our research purpose is want to test this movement patterns. Is this every place are the same? And next is we want to discussion the investigate the constraint about the movement patterns. The third is we want to optimize the population management because just we mentioned before it's now under the survival stress. Also, we want to fill the research gap because the previous research lacked the influence of habitat, substrate, and biota on the vertical movement. So we want to fill the research gap. And our research site choose on the North Australia, which called Osprey Reef, and is here. And we have two methods to get the data. The first one is we track the individual and track out for 78 days. When we have 10 mature and 10 mature male and 1 immature female. The second is we use a remotely operated vehicle, which we call ROV, to observation individual under the water, and we have 48 individual recorded and 5 were juvenile. And this is the ultrasonic, and we use it to monitor the location and the depth. And also it will collect data, and this data was using active ball tracking and fixed underwater station to record. And here's a result. And this is water temperature and depth profile in the Osprey Reef. And the blue line means the record routes, and the red spot is the record station. Just we know that if the depth increase, the temperature will decrease. And we just mentioned in the introduction is its survival temperature limitation is 25 degrees Celsius, and in Osprey Reef is about 100 meters. So as you can see, there's no individual above 100 meters. And here is the movement record, and different color line means different tag individual. And just we talked before, previous research will assume that in the nighttime they will prefer to stay in the deeper water depths, but just as the result shows, they are prefer to stay in the deeper depths, not in the shallow depths. And in the daytime, they stay in the shallow depths, not the depths deep depths. It's a different part compared with the previous result. Also, the percentage of the percentage rest time also support the different results. And here's the total resting time and for recording. And here's the depth we record. It will resting. And the previous hypothesis assumed they will stay in a deeper depth, so here should be more higher than the shallow depths. But as you see, the group in the osprey reef prefer to stay in the shallow depths than the deep depths. But the ROV dye profile give another different result, and each color line means a different location, and this greater have different color means the different number of animals seen. Like black is 1, yellow is 2, red is 3, green is 4, purple is 5, and here's the different record just we talked before. And as you can see, the time is 6 a.m. to 2 p.m. is daytime, but these groups prefer to stay in the deeper depths. So we want to discuss the biological constraint about the Nautilus. The shallow is limited by the temperature we talked before, and the deepest is limited by the stress. And if we go down more deeper, it will face the shallow impulsion problem. And shallow impulsion problem means because of imbalance inner and outer water stress, and the water stress will squeeze the shell and cause it damage, just like we see here. The shell is damaged, so it cannot survive. And the other is about the buoyancy mechanics. If the water depth is deeper than 250 meters, the osmotic pressure will force liquid into a chamber, just like we see in the background. So the Nautilus will get the negative buoyancy, which means they will sinking in the water. And if the water depth is shallower than 250 meters, they can remove the liquid from the chambers, so it will get a neutral buoyancy, and which means it can floating of stability and don't need to spend too much energy on this buoyancy mechanics. Then here's about a region comparison. I choose the PLoS because it's the most studied site, and here's PLoS prefer and we can see it have a very similar habitat, just like here. But PLoS lack the hiding place, means shorter, so and the Nautilus size is large. So it means it cannot hide in this place. So they need to go to a deeper water depth for avoid predator or survival stress. But in osprey reef, they have rocky reef for hiding place, and they have small size, so they can hide in the rocky reef. They don't need to consider about the go down to a deep water depth. They can just hide to avoid, and it can decrease the risk of the predator or survival stress. Then A and B we have talked before is in PLoS, and they are also lack of hiding place and large size. And C is Papua New Guinea. Papua New Guinea, because it has very steep habitat, just like here. It can move. The Nautilus can move quickly from the shallow to depth. So the survival stage also become, they will just migration into a deep depth, then more convenient than the hiding place. And foodability also is a factor will impact the movement patterns. Osprey reef have a different substrate type in different depths. And in 100 to 250, the substrate type is steep and rocky, and it causes the low catch rate for Nautilus to catch a prey. And in 300 to 450, the substrate type changes to gradual and salinity, and it provides a higher catch rate for Nautilus to catch the crustaceans or prey. And in Fiji, it's about 300 meters, and its substrate type is muddy and substrate. And it also provides the best catch rate for Nautilus. And New Caledonia, because it's located in a low latitude, so the water temperature is lower than the other place. So it's located on the 50 to 75 meters. And its substrate type is reef tallow, and reef tallow means like a reef sand, and they are near the reef wall, so it also provides the good environment, so you have the optimal catch rate for Nautilus. So the conclusion, what will impact the movement patterns is these three key factors. One is preferred feeding habitat. The second is buoyancy regulation. The third is avoidance of visual predator. It will change their survival stage. And here's my presentation. Thank you for listening.